Let's take a look at compound interest. The main function that you're going to see for compound interest uses the discrete equation where we have a equal to p times 1 plus r over n to the n times t power. Now if your packet for some reason doesn't have n times t there, please add the t. As far as defining what these all mean, a stands for the initial amount, or the final amount, excuse me, the final amount that we end up with. P is the initial amount, the principal. R is the interest rate that we're working with. N is the number of times that your interest is compounded each year, so compounded once a year, or 4 times a year, or 12 times a year. And T is the number of years that the loan is lasting, or the investment is lasting. So let's take a look at an example here. You invest $500 in a savings bond on your 18th birthday, or on your 8th birthday. This bond pays an annual interest rate of 6% compounded quarterly, 4 times per year. How much is this bond worth on your 18th birthday? First thing we need to do is figure out what our variables are, and we're going to start by looking at our equation. We need to figure out A, the final amount. Well, that's what we're trying to calculate. What is it worth when we're done? So we don't know A. P is how much we started with. P is going to be $500. So we can write that down here. P is $500. Next one we're looking for, R. R is going to be the rate that we're working with. So if it's an interest rate of 6%, then you write the rate as a decimal as 0.06. Make sure you write it as a decimal. Don't write it as 6. N is the number of times it compounds each year, and it says compounded quarterly, which is 4 times per year. So N is going to be 4. Let's color that green real quick. So N is going to be 4, and that's going to show up a couple places in our equation. And then finally, T is the number of years that the loan lasts. It says I got the savings bond on my 8th birthday, and I want to know how much it's worth on my 18th birthday. So the difference between those two is 10 years has passed. So T is going to be 10. I'll go ahead and mark that on here also. Alright, now we just need to pop all these into our equation. So A is going to be equal to 500 times 1 plus 0.06 over 4, R over N, to the N times T power. So 4 times 10 is 40, N times T power. Once you pop this into your calculator, it's just going to give you an answer right away, and that answer is going to be 907.01. You're going to want to round it to a dollar amount with cents because it's money. So $907.01. Next example, we're going to use a different equation, a similar equation, but slightly different one to compute compound interest. And instead of compounding every 4 times a year or 12 times a year, it's compounding all the time in this problem. So in this example, you invest $500 in a savings bond on your 8th birthday, same as before. This bond pays an annual interest rate of 6%. Again, nothing changes, except this time it says it's compounded continuously. How much is the bond worth on your 18th birthday? Well, when it's compounded continuously, we're going to use this new equation up here, using E. So A equals P times E to the RT. A is going to be the final amount. That's what we want to know, so we won't have that. P is going to be the amount we started with. That's the $500, so we're going to get our $500 in there. Then E, well, that's just the constant E, so then we need to figure out R. R is going to be the interest rate. Interest rate is 6%, so that's 0.06. You just have to remember to write it as a decimal. And then T, number of years, we went from the 8th birthday to the 18th, so that means 10 years has passed, so T is 10. And all you have to do is pop this into the equation now. We're going to have A equals to 500 times e to the 0.06 times 10 power. And so that's just going to be the 0.6 power. Now you pop this all in your calculator, and it's going to give you an amount, $911.06. Very close to the last example, slightly higher because it's compounding more frequently. It compounds all the time, but not a whole lot more. So the amount of times something compounds per year isn't going to make a significant difference. All right, and that's investments.